Alright, so we're going to start this area section with 11.4 in your notes, but notice your notes don't say this, but this is 11.4a. That's because I split this into two sections. So we're going to start with the squares, rectangles, and parallelograms area, and then in just a little while we'll go back and we'll get the triangles. So that'll be called 11.4b, but you're only going to do the notes today, or right now, that are about squares, rectangles, and parallelogram area. Alright, so we have some area formulas. They're all pretty similar. So the area of a square is the area of a square is the square of the length of its side. So if you notice here we have tick marks all around, and we're calling this side S. So for the area of a square, you can do S, this side, times this side, another S. So that would become S squared. Now, personally, I use the formula base times height instead. Even though the base and the height are the same, this formula I'm more familiar with, so I just remember this formula and use it for squares. But whichever one makes more sense to you will work. Then the next one, the area of a rectangle, is the product. So remember, product means multiply of its base and height. So again, for a rectangle, we're going to do base times height. Area of a parallelogram is also the product of a base and its corresponding height. So the area of a parallelogram is also base times height. Now the tricky part of a parallelogram is this is the base, right? Because it's one of the parallel sides. These could have been the bases, but in this picture they're just not. But the parallel sides can be bases, and then the height has to be perpendicular to it. So that's what it says here. Either pair of parallel sides can be used as bases. And in this picture, we use these because we have a perpendicular line here. We don't have any perpendicular with this. And the height is the perpendicular. Remember, that means crosses at 90 degrees. So that's why that right there tells me it's perpendicular between the bases. So this has to be the height. This right here is not the height because it's not perpendicular. So that's the tricky part about parallelograms. You have to be really, really careful and make sure you're looking at a height and not just one of the slanted sides. All right, we'll do some examples, and then you'll have time to practice on your own. So the first example that we're going to do, or all three of these examples actually, we're going to find perimeter and we're going to find area. Perimeter, remember, is the distance around. And the area is the space inside. So we have two different things. Perimeter, we're just adding all the sides. Area, we're using our formulas. So in this shape right here, it looks like I have a parallelogram. We don't have markings, but we're going to assume that this is a parallelogram. And then right here, I see a perpendicular. So I see a 90-degree angle. So that means that this right here is probably going to be my height. And that means where it's making the 90-degree angle, this side right here would have to be my base when I'm doing area. So I'm going to go to area first. And area, remember, for a parallelogram is base times height. And because I found my 90-degree angle, I know that this right here is going to be my base. And then this part right here is going to be my height. So when I do my area formula, I've got 12 times 4. And then I know that 12 times 4 is 48. This doesn't have any units on it, but I am going to just say units, and then because it's area, I'm going to square it. So I know that this is 48 units squared for the area. That's the space inside the shape, but then I still have to do perimeter. Perimeter is where I add all the sides. So when I do perimeter, I have this side's 12. And then in a parallelogram, I know that this side right here is also 12. And then in a parallelogram, the opposite sides are congruent. So if this is 6, this is also 6. So for the perimeter, I've got this side 12 plus 6 plus 12 plus another 6. And that ends up being 36. So capital P is perimeter. It's 36. And then we don't have units, But remember, for perimeter, it's just units, not squared or anything like that. Now, one thing going back to the area, right? We used this side as the base and this side as the height. There is another 90-degree angle in this picture, right here. So technically, remember up here it said that either pair of parallel sides can be a base. So I could have used 6 as the base, and if I had done that, this side right here makes a 90-degree angle, even though it's not actually with the 6. If I extended that, then it would make a 90-degree angle. So I could have used 6 and 8 instead, and I'm just going to show that on the side to show you that you get the same number. So remember, base times height. If I used a base of 6, and if I used the height of 8, 6 times 8 is still 48. So it would still work out, and we're still doing area, so units squared. So in this parallelogram, you had an option of which base to use. You don't always have that option, because you don't always have two 90-degree angles given, but in this one you did have that. Alright, next one. Now I'm going to change this problem just a little bit. It says to find the area of all of this, but we haven't done all these other shapes yet. So instead, what I'm going to do is we're just going to find the area of the parallelogram part. Like I said, because we haven't done the other shapes yet, later on you might be able to find the area of this shape, but as of right now, we are only going to find the area of that orange, the shape in orange. So this part right here is what we're finding the area. We are not finding this area, and we're not finding this area. Alright, we know this is a parallelogram, right? So for area, we know we have to do base times height. Then, if I look in this picture, my base could be 40 because it has parallel. My base could also be 17 because it has parallel. And I don't have right now I don't have what is a height because I don't have what is 90 degrees. So like this side right here is making a 90-degree angle, which with what would be the top base, but I don't know how tall that is. What I do know though is that I can find that number. So this number right here, this height, I need to find it because then I can plug into my formula. So I'm going to go off to the side just a little bit, and I'm going to say, okay, I need to look at this shape right now, and I need to find that height. And what I know is that this side is 8, and then since it's a parallelogram, this is 17, so is this. So I see a right triangle. I'm missing one side, but I'm given 2, so I figure I should use the Pythagorean theorem. I'm going to use this as A, this is going to be my B, and this will be C because it's across from 90. So I have 8 squared, right? A squared plus, instead of B, that's my height, squared. And then instead of C, I have 17 squared. 8 squared is 64. Then I still have H squared. And 17 squared is 289. I need H by itself, so I have to get rid of the 64. And then I have H squared, and I have 225. I need to get H by itself, so I got to get rid of a squared with the square root. And then I have H equals 15. So I just found out that this part is 15 meters, the height. So now I know that I have to use the base of 40, because the 40, then it makes a 90 degrees, the height, with the 40, not with the 17. So when I go back to my formula, I've got my base is 40 times my height I just found out is 15. And when I put that in my calculator, 40 times 15 is 600. And this time we do have units, we're measuring in meters, but since it's area squared. Alright, we still have to find the perimeter, and remember we're only doing the orange part for perimeter. So we have to add up all the sides to find the distance around. If the bottom is 40, the top is 40. And we already figured out that those are both 17. So we have 17 plus 40 plus another 17 plus another 40. When I add that all together, I get 114, and since it's perimeter, it's just meters, because we're measuring, like if we measured with a ruler, it would be 114 meters all the way around. Okay, C is a little bit more challenging, only because right now it's not a shape that we know. It's not just a rectangle right away, but what I see is that I think I can split this into shapes that I do recognize and that I can find the area of. So right here, if I make a line, now I just made a square at the bottom. So if this side's 5, I know that this part's 5. And if this bottom part's 5, I know that this top part's 5. And then on the top, I have a rectangle. I know how long my rectangle is. It's 9. Which means down here, I have 5 over on this side, and I know that it has to equal the top, so I know that this part would have to be 4. And that's talking about this little outline piece right here. And then the same thing happens over here. I don't really know how tall my rectangle is right this second, but I know that altogether the rectangle plus the square makes 9. So in order to make 9, I know that this has to be 4. And because it's a rectangle, if this side is 4, this side is also 4. Now that I have all those measurements, I know that I have a rectangle and I have a square. So I'm going to kind of separate it. So a rectangle and I have a square. And remember, I told you I use the same formula. So for rectangle, it's base times height. For square, I could do one side squared, but I prefer the base times height formula, so I'm just going to use that again. And let's start with the rectangle. So for the rectangle, my base, altogether, this base is 9. And the height of my rectangle is 4. So my area of a rectangle is 36. And I'm measuring in meters squared. For the square, the base is 5. The height is also 5. So the area is 25, and we're still measuring in meters squared. Now, since I want the area of all of this shape together, that means I have to add these two areas. So I have to take the rectangle plus the square, and when I add that together, that gets me an area of 61, and since it's still area, I'm still measuring in meters squared. So there's my area, and then I still have to go back and do the perimeter all the way around this whole shape. So I'm not talking about them separately anymore. I'm going to add everything. So when I'm going around the outside, I go 4 plus, then I have 9 when I go that way. And then this way, I could do plus 4 plus 5, or I know that together this whole side is 9, so I'm just going to add it as 9. Then when I go on the bottom, it's 5. Then when I go up this side, it's another 5. And then when I go across here, it's 4. And that gets me back to where I started. So if I were to like walk, that's how far I walked to get back to where I started. When I add all that up, I end up with 36. And I'm measuring in just regular meters since it's perimeter. All right, you're going to practice this, and then you also have notes about triangles coming up.